Hello, my name is Albert. This is a recording for assignment 1. For assignment 1, I have used an adjacent matrix for my directed graph, and these are test cases that I've solved. For the first case contains, it'll check if the entered ID is in the graph or not. For adjacent, we'll check if there's an edge between the two entered IDs. For add vertex, it'll add a vertex to the graph with the entered ID and weight. For add edge, it'll add an edge to the graph with between the two IDs and the weight. For remove vertex, it'll remove the vertex with the associated ID from the graph. For remove edge, it'll remove the edge associated between the two IDs. For in degree, it'll count the number of edges going into the vertex starting from 0, and it'll count up every time an edge going in is found. Same for out degree, but for edges going out of the vertex. For degree, it'll call in degree and out degree for the total number of degrees for total number of edges associated with the vertex. For number of vertices, it'll count the number of vertices in the graph starting from 0 and count up every time there's a vertex is found. For edge count, for number of edges, it's the same. It'll count the number of edges in the graph. For get vertices, it'll return a vector of vertices and it'll add the vertex to the vector every time a vertex is found. For get neighbors, it'll return a vector result for each neighbor associated with the entered ID. For get neighbors, it'll return the second for get second order neighbors. It'll return the second order neighbors in a vector result. For this, I have marked all the vectors as unvisited, and the first vector to be visited is the initial vertex, where the entered vertex cannot be a second order neighbor of itself. It'll find the neighbors of the entered vertex, and it'll find the neighbors of it'll find the neighbors of the entered vertex. For reachable, I've used breadth first traversal. In here, I've marked all the vertices as unvisited and use a queue for my traversal. For contain cycles, I've used 3 sets: white, green, and black. And for this, all the nodes will initially be in the white set, and while traversing, the nodes will go to the green set, and when they have finished traversing, when the nodes have finished traversing, they will go to the black set. And if a node that is found in the green set, and if a node is found while traversing that is in the green set, so the current node is also in the green set, it'll return true for contained cycles. For the first traversal, I've used the iterative approach. I marked all the nodes as unvisited. I've used a stack, and it'll return the all the vertices in the vector result in the order in which they were visited. For breadth first, like reachable, I've used a queue. I've used a queue, but instead of returning true or false, I've used the vector to return the nodes in the order they were visited. For out tree, it'll return a tree starting from the entered node. For this, I mark all the nodes as unvisited, and I've used a queue for with a pair, and in here I'll add the vertex and the edge for the tree, and the final tree will be returned with the variable tree.